Hey there, in this video we're going to cover how to solve polynomial and rational inequalities. So we're going to start with the regular quadratic polynomial. So how do we solve something like this? And you encounter a lot of these inequalities when you're solving for a domain, except for domain you may have something like greater than 0 if x squared minus x minus 6 happen to be under a square root, for example. So the first thing is to factor completely. So what two numbers multiply to -6 and add up to -1? And so those will be x minus 3 and x plus 2. And so once we have it factored, then we want to find the zeros of the polynomial. The zeros are the things that then we put on the number line. So find the zeros of the polynomial. So the zeros are when x minus 3 equals 0 and when x plus 2 equals 0, right? Each of the factors. So here I get x equals 3, and this gives me x equals -2. So I place the zeros on the number line. So once I plot the zeros, this breaks out the number line into 3 regions, 3 different intervals. So we need to check what does this product look like in those intervals. So here is when they are 0, and it's not included, so I'm not gonna fill in those circles. So now I want to make sure that the product, right, the product of these two, we want it to be less than 0. So less than 0 means we want the product to be a negative number. So how do we do that? We pick test points for each region. So we're going to pick a test point in the region from -infinity to -2. So I can let x be -3, for example. And then we're testing this product x minus 3, x plus 2. So when x is -3, you have -3 minus 3 and -3 plus 2. Remember, we just want to see if it's positive or negative, so don't necessarily care too much about the value. So -3 minus 3 is a negative number, and -3 plus 2 is also a negative number, and negative times a negative is positive. So the product here is positive, so we don't want that because we want the product to be negative. So we're looking for the interval that will give us the product is a negative number. So let's try, what about the next interval? So the next interval is -2 to 3. So in -2 to +3, we can be nice to ourselves and choose x to be 0, right? You go from a negative to a positive, so you have to cross 0 in there. So I'm going to have 0 minus 3 and 0 plus 2. Again, we don't care too much about the numerical value more than the sign, because we want to see, is the product positive or is the product negative? So 0 minus 3, that's a negative number. 0 plus 2, that's a positive number. And negative times a positive is negative. And so, yay, we do want that. The product is negative, so I'm going to shade that. I guess I could highlight it as well. So we do want that. The product is negative there. And now let's test the third interval. So in the interval from 3 to infinity, what's happening? Let's let x be something bigger than 3, anything that's in there really, so I can just pick at random 10. Anything from here, you're just picking a representative. So when you put it in here, 10 minus 3 and 10 plus 2. So 10 minus 3 is a positive number, and 10 plus 2 is a positive number. So positive times a positive is positive, so I don't want that. So the solution to this inequality then would be in interval notation. We can say the solution is x in the interval -2 to 3, not included. All right, so let's try a different example, something. I'm going to give it to you in factor form, so that's something a little more complicated. I didn't finish my statement there. X plus 2 times x minus 1 squared times x minus 3, let's say not greater than or equal to 0. So this is in factor form. So this is going to end up being what? X times x squared times x. So this is going to be a 4th degree polynomial. But let's practice just the factor form. Normally when you encounter a polynomial inequality, the first thing is factor completely. This is already factored, so the next step is find the zeros. So what are our zeros? the zeros are going to be whenever each factor is 0, right? So x plus 2 is 0, when x is -2. When x minus 1 square is 0, which means when x minus 1 is 0, so I get x equals 1. And when x minus 3 is 0, which would mean when x is 3. So x equals 1, this 0 has multiplicity 2 because the factor is squared. So we put those on a number line. Okay, so we do have to use the number line or some sort of way to check them. So I'm going to put -2, 1, and 3. Those are my zeros. And so I'm going to put zeros on those circles. And are they going to be open or solid? Because we have the equals, that means that we get to include them. So we're going to fill those in. So make them solid. And now notice that because we have 3 zeros, our number line has been split into 4 regions. So for our test points, we're going to be checking the 4 regions. So for -infinity to -2, and we'll see what that is. So let's pick something in there. Let x be -3. You could have picked -4, any representative of that. And so we're testing it into the original, right? So I'm testing into x plus 2, x minus 1 squared, x minus 3. And what do we want in this case? Greater than 0 means we want the product to be positive. So that's what we want. So let's check it. So when x is -3, I'm going to have -3 plus 2, -3 minus 1 squared, -3 minus 3. So -3 plus 2, that's a negative. -3 minus 1, that's a -4, but when you square it, you're going to get a positive. And -3 minus 3, that's a negative. So you end up with negative times a positive, which is negative times a negative. So I get positive. So from this interval, we get a positive, which means we would want that. So I'm going to shade that. So let's go ahead and shade it. So we do want this. Now let's check the next interval. What about from -2 to 1? So from -2 to 1, right, I'm using brackets because those are included. So again, be nice to yourself. Let x be 0. When you're going from a negative to a positive, you have to cross 0. So let's put it in. So I'm going to have 0 plus 2, 0 minus 1. There should be a minus there. And then square. And you may be realizing that since we're going to be squaring that term, it won't really matter what we put in there because anything square is going to be positive. So I'm going to have positive times a negative. So positive times positive is positive, times a negative, I get a negative. So the product of all these things is negative there. So we don't want, because we're looking for the product to be positive. The third interval is between 1 and 3. So let's pick something between 1 and 3. 2 is a nice thing to pick. Sometimes we have to pick fractions, but that's okay. So in this case, we get a nice whole number. So 2. So I'm going to have 2 plus 2, 2 minus 1 squared, and 2 minus 3. So 2 plus 2 is positive, right? We're already seeing that whatever you put in here, when you square it, you're going to get positive, and then 2 minus 3 is negative. So I get a negative as well. Oh, so I get negative, but I am including that one. So that makes our answer interesting. And then let's check the last interval from 3 all the way to infinity. So let's pick something larger than 3. So let's say 5, right? You just need a representative. You could use 4, 5, 6, any number. So 5 plus 2, that's positive. 5 minus 1 squared, that's going to be positive. And then 5 minus 3, that's going to be positive. So now I have everything is positive. So the product of all positive numbers is positive. Since we're looking for the product to be positive, I will shade that as well. So how do we write this answer? Because I want to include the interval -infinity to -2. And then we want to include the interval 3 to infinity. But I also want to include the 1 because you can equal 0. So the way that we write that in interval notation is we're going to have to use also the brace notation. So our solution will be x is in the interval negative infinity to minus 2 bracket union. I want to include that 1, right? Because that's where x is equal to 0. So I want to be able to include that, but it's just a single number. It's not an interval. So then we call it the singleton 1. So we use the brace notation, union, and then bracket 3 to infinity. If we were not including the zeros, right, this says we want the product to be greater than or equal to 0. So we were including it. So because it's 0 there, we have to include it. If it was just greater than 0, then my only intervals will be minus infinity to minus 2 parentheses, union all the way over here, parentheses 3 to infinity, because then none of the zeros will be included. But in this case, because we want to include the zeros, right, when x is equal to 0, so we want to include negative 2, we want to include 1, and we want to include negative 3, then I have to include that singleton. And so how do you include a singleton? We use the braces notation. Okay, so I'm going to try just one more example, but I will do a different video for this one so that, because it will require more time, but you can, at the end of this video, try it on your own, see what do you think you would do to solve it, and then go on to the next video, part 2, so you can see how I solved it. All right.